So welcome to K arrays or M arrays. There's a couple of different names. The K or the M portion is the number of maximum children that a tree can have. It is built of an array of nodes. So that's one of the nice things about it. You and I are very used to arrays. They're easy to manipulate, stuff like that. So a lot of people like working with them, but there's a problem. There can be empty spots in an array to denote a missing node or a missing child or whatever. The only bad part is that this is really good if you know that your tree is going to be chock full. Like there's really not going to be any spaces. Every option is taken. Every child is developed. But look at the example that I have for you here. Just pretend this is a K3 array. And here they didn't use all the options, so you're going to be left with a lot of holes. So again, this is the drawn representation of it, and this is the actual array representation of it. Here's the interesting part. Notice 8, 9, and 10, there's no kids at that location in the array. They can't suddenly have kids. So this is like the Michael J. Foxys in Back to the Future. If his parents don't get together, then he's never born. And then his children are never born, and then his children are never born, and it keeps going from there on out. So this empty space that you see is only going to get worse as we get wider and deeper into the tree. That's a massive memory loss, and well, again, because it's an array, we have to build the array with the empty blocks in between. So there's a lot of wasted space if the application that you're building doesn't utilize every single option or child that it can use. So there is some goods and there is some bads to a K-array. So other than just going over the bad things, again, there's some really nice things about it if you know you're going to be using every one of the options. And that is there's some easy formulas to figure out if and where you got to move. So if your I is the current index, and you want to find a parent, it's very easy. You do your K plus your integer or your current index number, minus 2 divided by K, you get your inner division, and that's how you get your parent. I'm going to show you that right now with the screen. If you want your first left child, your first child, second child, third child, whatever number of children, because remember, it may not be binary, there's also a very simple equation that's highlighting right now. And again, I'm showing you an example of it right now. So that's pretty easy on figuring out where your parent and stuff like that. There's no pointers, there's nothing like that. So that's kind of nice. And then we have another one for if it just happens to be a binary K-array tree, and that is, well, you see right there the parent of i's, and I'll go over these equations here in a moment, but notice the equations on how to figure out what your parent, your left child, middle child, right child, whatever number of child it is actually very, very easy in a K-array format.